So once again, hi everyone. In today's video, we are going to discuss the further topics in angle of deviation. In the last video, we have covered the derivation of angle of deviation, which was delta equals to I, which is angle of incidence, plus E, that is angle of emergence, minus A, which was prism angle, and this A was equivalent to the refractive angles inside the prism R1 and R2. R1 was the refractive angle at first surface, and R2 was considered as incidence angle at the second phase. So further we have to discuss the factors on which this angle of deviation depends. See, moving to the next slide, we will see that I have written here there are four factors on which the angle of deviation depends. The first one is the angle of incidence, that is I. See, by the formula itself, it is very much clear that delta is dependent on I, E, and A. But I is something which we can change, but E is dependent property on I itself. For a particular I, there will be a separate E. So E indirectly depends on I only. And the A, that is the prism angle, obviously we can change the prism angle to have a different delta. See, it has been experimentally found out that as we increase the angle of incidence, as we are going to increase the angle of incidence by a bit by bit, then we have found out that the first this delta, that is angle of deviation, first it decreases till extent which is delta minimum, called as minimum angle of deviation. After that, if we further change or further increase the angle of incidence, it has been found out that this delta, that is angle of deviation, will increase. Okay, so by changing the angle of incidence in an increasing order, first the deviation angle first decreases. It decreases till a certain point. After that, it starts increasing. Okay. So the first dependence, or the first factor on which the delta is dependent, is angle of incidence, which is like this. And if we draw a graph for this, that angle I and delta, it has been found out that this graph will be something like this. Something like this. Let's say this is the two axis on which I'm considering my graph. Okay, so let's say this is the angle I. This is considered as axis of angle I, and this one as angle axis of delta. So it has been found out that if we start increasing I, we have found out that the angle of deviation will vary something like this, and this is the point at which we will have minimum angle of deviation. All of this graph has been plotted experimentally by the experimental data. And for experiment, it has been said that instead of changing the angle of incidence by changing the incident ray at different angles, we can keep that angle of incidence as same point, or as it is, and we can change the angle of incidence simply by rotating the prism. So that if we will rotate the prism, this normal will change its position, and hence resulting in change in the angle of incidence. So this was the first point. I hope you all have got the first point. So we have found out that how the angle of deviation depends on the angle of incidence. See, for this value delta minimum, see, the delta will be minimum when we will see the incident ray when incidented on the first surface after incidence, when the refracted ray gets parallel to the base of the prism. This is the scenario where the delta is found to be minimum. So delta minimum is found at the when the incidence ray after refraction gets parallel to the base. And when this happens, it has been found out that R1 becomes equals to R2, resulting I and E becomes equal. So by replacing these values in our equation, which was I plus E minus A, we can write it as I plus E. In place of E, we can write I only minus A, which will become 2I minus A. So this is the formula for the angle of minimum deviation, that is 2I minus A. So moving to the further, we will discuss about the refractive index of a material of a prism. how it depends on how it affects the angle of deviation. Okay. Next is the refractive index of the material. Again, see, uh, on refractive index of the material, delta or angle of deviation has been found out that if the refractive index of, let's say, there are two mediums, medium 1 and medium 2. If the refractive index of medium 1 was greater than medium 2, then for a given value of angle of incidence in both the mediums, it has been found out that delta for one will be maximum or more compared to the delta for the second medium. So if the refractive index of a medium is higher compared to the refractive index of another medium, then for the same angle of incidence, the angle of deviation will be more in the first medium compared to the second one. So this is how it depends on the refractive index or material of the prism. Third one is the prism angle. We can see by the formula only. If we are going to change the prism angle, we will see that there is a variation in the angle of deviation. Okay, so the relation with the prism angle is like this. If we are going to increase the prism angle, so the delta is going to change. And by what factor it will change? The angle of deviation will also increase. If we are going to increase the prism angle, then angle of deviation is also going to be increased. Okay. And the last point is, or the last factor is the color or wavelength of light which we are going to use for this phenomenon of refraction through a prism. So we know that the relation is we know that there is a relation between mu and lambda. See, we know the formula for mu as C by V, right? And we know that V could be replaced by, because we know the formula for V is F lambda, and we know that frequency never changes, but lambda wavelength changes by changing the medium. So if let's say if we are going to change the wavelength or going to increase the wavelength, right? If you're going to increase the wavelength, then this whole value, the value of mu is going to decrease. So if we are going to change the wavelength or if we are going to increase the wavelength, by increasing the wavelength, mu is going to decrease. For mu to be decreased, the result will be delta will also gets decreased. Okay, so it is inversely related to the wavelength of light. So higher the wavelength of light, lower will be the angle of deviation. And we can conclude from this that mu of violet light is greater than mu of red light, right? Which results that delta for violet will be maximum for delta for red light. And we know that lambda for violet light is least compared to the lambda for red light. So all of this is related by this equation. Okay. We can see from the diagram, if we have any other doubt, what terms I have used. This is I, that is angle of incidence. This one is R1, the refractive angle at first surface, and this is R2, considered as in angle of incidence as a second surface, and this is the angle of emergence, and this is the deviation angle, which I have mentioned with blue line or blue letter. Okay, so this is for this video only. If you feel any doubt in this video, be free to ask. We'll try to cover that. And for the students who are asking for the video of class 9th or another chapter, please wait for some time. I will be uploading all those videos soon. So thank you so much. Thank you so much for watching and supporting me.